Hi guys, now I'm going to show you how to solve the question. So the question states that we have to ask manufacturers to make cylindrical crans to hold 255 cm cubic of our sambal. So the sambal ikan masin volume is 250 pi. The volume formula for cylinder is equals to pi r squared h. Now we can rearrange these two into one equation. So 250 pi equals to pi r squared h. Now the question also states that we have to find the dimension such the surface area is as small as possible. So we can find the surface area for the cylinder, and the surface area is equals to 2 pi r squared plus with 2 pi r h. Now the problem is we have two variables in one equation. In order to solve this, we have to make any one of these variables as the subject, and we have to choose any of these two equations to rearrange. So in this case, I'll choose the volume equation just now to make the h as the subject. So 250 pi equals to pi r squared h. Now we have to divide both sides with pi r squared divided by pi r squared equals to h. So the pi can be cancelled out, leaving 250 pi divided by r squared. So this is our h value. Now we can substitute in the h just now into the surface area formula. So surface area equals to 2 pi r squared plus with 2 pi r and the value of the h, 250 divided by r squared. The r can be cancelled, and then just write it back, plus 2 multiplied with 250 is equal to 500, and pi divided by just 1 r. Right. So since we have to differentiate this equation later, it will be easier for us to rearrange this equation and put this r on top. So it will become 2 pi r squared plus with 500 pi r to the power of negative 1. Just like what I said just now, we have to differentiate the surface area in order to find the value of r and assume that there's no rate of change of dA over dr. So dA over dr will be 0, and then let's differentiate the surface area formula. So 2 pi r squared will become 4 pi r minus with 500 pi r negative 2. Okay, now we have to find the radius value. Just substitute the value of dA over dr just now, which is 0 pi r. Now we have to plus both sides with 500 pi r to the power of negative 2. So it will be 500 pi r to the power of negative 2 equals to 4 pi r, and we can divide both sides with 4 pi. 500 pi r to the power of negative 2 divided by 4 pi equals to r. So the r will be, this one cancel, this one, and 125. Right, so the r is equals to 125 r to the power of negative 2, and if we divide both sides with r to the power of negative 2, this side will be r cubed equals to 125, and then third root both sides, the root of 125 will become 5. Now we already have the radius value. The h just now is equals to 250 divided by r squared. So we can find the value of h. The value of h will be 250 divided by 5 square. 5 square is equal to 25. So 250 divided by 25 is equal to 10. So the h is 10. Right, now we already have the value of h is 10 and the radius is equal to 5. Now take a look back at the question. Says that we have to find the surface area as small as possible. So the question 1 us to find the minimum value for the surface area of the cylindrical can. In order to do that, we have to differentiate the surface area for the second time. So it will be d double prime A divided by dr square. So it will be 4 pi plus 1000 pi r to the power of negative 3. So minimum value, we all know that if the second derivative are greater than 0, so it will become the minimum value. Hopefully when we substitute in the r, we can get the value of the second derivative greater than 0, so we'll have the minimum value. So let's substitute the r equals to 5 inside the second derivative. 4 pi plus 1000 pi, the r is 5, negative 3. 4 pi plus 1000 pi 100 1 over 125, so it will become 1000 divided by 125, so 4 pi plus with add pi is equal to 12 pi. So the second derivative is greater than 0, so we have the minimum value. That's it. That's the answer. Thank you.